All right. This entire chapter, chapter 7, is all about simplifying algebraic expressions. Now, an expression is not an equation. We're not solving for x. We're not solving for x comma y. We're not finding where two lines intersect anymore. We're not finding where two parabolas intersect or anything. We are kind of just going elsewhere. And what we are going to do is we're going to take things like this and we are going to rewrite it. Let's go to the next page. We're going to take all of these algebraic expressions and we are going to rewrite them and simplify them. Now, this chapter has a lot of rules, but the rules come from things that you can discover yourself. And I will show you how you can just discover these rules continuously. You don't have to memorize the rules. But once you have the idea, pretty much you'll just understand the rule and you'll just go from there. Question, Mr. Suarez? So we will rarely use our calculator. Rarely, because we won't have to. It's just really easy manipulations of numbers and stuff. You know, maybe for certain things we will, but you'll be able to figure it out. There are rules for negative exponents, and right now we're going to be talking about exponents, okay? Exponents. And after today, my hope is that we will be able to know what to do when we see negative exponents. We'll be able to know what to do when we're multiplying things with exponents. We'll be able to know what to do when we're dividing things with exponents. And that's it. So negatives, multiplying, and dividing. Well, there are rules, and we will trip up on these rules. Now, what I ask you to do right now is to get out another sheet of paper, because I'm going to ask you to do something, and I'm going to ask you to simplify something. I guarantee you, you're all going to get it wrong, or it's going to be a little bit off from what I'm looking for. I want you to try to do the practice work on a sheet of paper, and then the correct way, you will do it on your notes. There are exponents to exponents, yes. We will do those. It's not going to be like 5 squared and then a little tiny 3. Like the little tiny 3 would be looked at like this, 5 squared cubed. Okay?
Wouldn't that just be cubed of what? 5 squared?
Yep. 25 cubed. Okay, everybody have paper out, ready to go.
She go off the basketball, shouldn't he? He's a beast.
Kobe, right there. All right. What is an exponent?
The number of times you multiply the number.
Exactly right. It's a teeny number we throw above a number, like up to the top right corner, that signifies how many times you are going to multiply that number by itself. This is the exponent. So if I see 5 to the second power, that is just 5 times 5, 25, piece of cake. If I see 2 to the fourth power, that's 2 times 2 times 2 times 2. 2, 4, 8, 16. If I see 3 to the first power, that's just 3. That's it. If I see negative 2 squared, Negative 4. I don't know. What is it? We have two ways to look at negative 2 squared. One is negative 4. One is negative 4. You figure it out.
Negative 2 times negative 2.
Yep. Order of operations says you do exponents before you do multiplication. I could rewrite negative 2 squared as negative 1 times 2 squared. Here, you could write this as negative 1 times 2, but it's in parentheses. Parentheses come first, so that's negative 2. Take that squared. This is 4 times negative 1 or negative 4. This is negative 2 times negative 2. This is positive 4. What if it was cubed? It would be negative 2 times negative 2 times negative 2. That would be negative 8. A negative times a negative is a positive, times another negative is a negative. Both of them would be negative in that case. Miss Clemens. Well, so this one is saying, really, if I say it out loud, it'd say, okay, take 2 and square it, then multiply it by negative 1. Okay? Now, the parentheses would say, like, okay, take negative 1, multiply it by negative 2 first, because parentheses come before exponents. So take negative 1, multiply it by negative 2, done. That's negative 2. Then square that. Negative 2 times negative 2. That becomes positive 4. Got it? Okay. All right. Now, we have seen these before, but we are not really familiar with these. Now, variables to powers, it's not that bad. It's the same concept. If I have x squared, how can I write that out? Maybe in a long way. X times x. Good. If I have x to the 5th, x multiplied by itself 5 times. No big deal. If I have 3 times x squared times y to the 5th, well, 3, x, y, 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 y. No big deal, right?
Is that what you write as your answer?
No. What we will do is we will take 3x squared y to the 5th, and we will multiply it by x to the 5th. And you will be asked to simplify that. I'm just making this up. This is a random thing. You will see random things like this, and I'll say, what is this simplified to? Miss Clemens?
Would it be the 3x, x, y, 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 y thing times x, 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 x?
Yes. No. This would end up being, if I multiplied these two things together, I would take these 5 x's being multiplied and multiplying by these 2 x's, making it 3x to the 7th, y to the 5th. This is what we're doing. We will develop rules once we understand this concept of just taking these 5 x's and these 2 x's, making 7 x's, okay? Now, x squared squared. 2 ways to do it. You can say either this is x squared times x squared, or you could say this is x times x twice. Either way, what do you get? 4 to the x's, or x to the 4th, not 4 to the x's. No, yes, there is. We will deal with that later. Mr. Douglas, question. We will get there. Let's just start just understanding this, how you can write out, all we need to do is understand how you can write out these variables multiple times. After we've written them out a couple times and we've done a couple of these simplification problems, we will have the rule developed and we will then be able to not have to write them out anymore. This is just showing you how you can. This is not saying this is the answer. Okay? If I asked you to simplify x to the fifth, you'd say that's simplified. But if I asked you to simplify x squared times x to the fifth, you would say, yeah, that's x to the seventh. Okay? We'll get there, don't worry. Now, what about x squared? What if I change this to a 3? Do this on your piece of paper. What is x squared to the third power? Write it out. Right now, there are no rules that should be in your head. You should be thinking about writing things out, and then before you know it, we will develop the rule, and that rule will help us. What did we get? X to the 6. We should get x squared times x squared times x squared. I don't know why that's confusing. Let's all just right now, since this is the beginning of the lesson, I'm really just introducing this. We haven't gotten the rules yet. Let's just go with it, okay? So this can be written as x times x times x times x times x times x. How many x's are there? 6 x's being multiplied by each other. Now, this last one could be written as 3x squared y to the fifth times 3x squared y to the fifth. Right? I write out what I have twice. That's what you take square. Well, that also could be written as 3xx y, 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 y. This would be 3 times xx y, 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 y. What's 3 times 3? 9. What's x times x times x times x? X to the fourth. And what if I have 5 y's being multiplied by 5 more y's? Y to the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We just simplified that. Yes? We'll get there. We'll get there. You want to go straight to the rules, but we'll get there. We're going to skip this bottom part. We're going to do the negative exponents last because I feel like they're the most trickiest. So we're going to skip negative exponents. We are going straight to multiplication properties of exponents. This is 7.3. We will come back to negative properties of exponents last because that's the trickiest. We're going to do these 3, and then we will develop a rule. Okay? You guys, on your piece of paper, write down what you think x to the 8th times x to the 4th is. On your piece of paper. If you are unsure, do not guess. If you are unsure, you can always say, oh, x to the 8th is just x times itself 8 times, and then x to the 4th is x times itself 4 times. There's a rule that will always work for all of these. The rule is, when in doubt, write it out. Yep. A lot of people are saying x to the 32nd. Well, that would be x 32 times written out. Well, here are 8 x's multiplied, and here are 4 x's multiplied. Mr. Pemberton, do you think it's x to the 32nd? What do you think it is? X to the 12th is correct, because I have 8 x's times 4 more x's, x to the 12th. Okay, do the next one. X squared, x cubed, x to the 6th. What do you think that is? They're all dots. They're dots between all of these.
No, the next equation, because it's x.
Yeah, these are dots that you just can't see. If they're next to each other, they're being multiplied.
I kind of like it.
Okay. So, what did we get for this, Mr. Dollar, now that we got it?
I got 11,
Good. Okay, good. We got to do one more, and then we can go for the rule. Okay? This one. What's this one? Write it down on the sheet of paper, and then you're going to come back and write it down here. Don't write it down on your paper. Write it down on the lined sheet of paper so that you don't write anything down incorrectly. I want you to just write the correct answers on your paper. Mr. Cross, what'd you get? That's exactly right. You can't multiply these 4x's with these y's. They are different. This is not xy to the 9th or anything. This is just x to the 4th. This is y to the 5th. What you can do is combine these 4x's with these 2x's, giving us x to the 6th, y to the 5th.
So would you like times y to the 5th or just?
If you have them next to each other, there is an implied multiplication right there. You can put the dot, but you don't need it. Got it? Does that answer your question? Okay. So, go up 2 pages. Here's the rule. If you are multiplying things with exponents, what's the rule? Mr. Palmer, what's the rule? Add the exponents together. If we have x to the 8th times x to the 4th, add 8 and 4, that's x to the 12th. X squared, x cubed, x to the 6th, 2 plus 3 plus 6, 11. X to the 4th, x squared, 4 plus 2, 6. There's your rule that you just discovered and that you can continue to discover by writing things out. Add exponents. Of your like kind of variables. What's x squared times x cubed? X to the 5th. You can show that by saying this is x times x. This is x times x times x. 1, 2, 3, 4, 5. The next one I want you to do on your piece of paper. On your piece of paper, tell me what 3x squared, 4xy squared is. When in doubt, write it out. You ready for the correct answer? There is a 1 above that x. I can multiply 3 and 4 together, that's 12. I have 2 x's times another x, that's 3 x's being multiplied together, and I have 2 y's.
Is there always a 1 there?
Yep. Question? No, it's 4 times x times y squared. This is very important. This is what people are kind of getting confused at. This is multiplication. This being next to this is multiplication. This is x squared times x cubed. If I put a 4 in there, that's multiplication. 4 times x squared times x cubed. if I take this and multiply it by 2x squared, well, really, it's just 4x squared, x cubed, 2x squared, all next to each other, all being multiplied. Multiplication is a beautiful thing. You can multiply things in any order. You could take this 2 and multiply it by the 4 and you get 8. That's no big deal. I can take 2 x's here, multiply it with 3 x's here, multiply it with 2 more x's here, and how many x's are being multiplied? 7. That is this simplified. Okay? So let's go back to your piece of paper. Now that you understand this, try to do this one. And I'm going to change it up. It's 2x 4y squared 2x squared y cubed. So those 3 things can be multiplied together. But guess what? It's just every single little item being multiplied by every single little item. You can multiply things in any order that you want. Do it on your piece of paper first. And if you have any doubts, write it out. This should be on your piece of paper first. And then once you confirm you have the right answer, then you put it on your notes. This is 2 times x times 4y, y times 2x, x, y, y, y. 2 and 4 and 2 can be multiplied together to be 16.
So you can multiply the y's and the x's together?
That's just yx, you know? Like an x times a y is just xy. It's not like x squared y or something like that. I have x, 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 that is 3 x's being multiplied together. I have y, 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 that's 5 y's being multiplied together. Like I said, Mr. Cross, this is a doozy. Let's practice. Questions?
Is there a way where you can play it down? Like kind of like a problem?
You just multiply your like terms, you know? You just see how many like terms you have. If you're multiplying it, you end up adding your exponents. The 2 y's, I multiplied the 2 y's by the 3 y's to give me 5 y's. Nope, because it's y. Y. 1, 2, 3, 4, 5 y's being multiplied together. That's y to the 5th. Okay? You add your exponents when you are multiplying terms of like variables. So go back to the multiplication. What is y squared x y to the 4th? y6? Good. The x is there, don't worry. Now you can put it next to each other, or you can just put a dot in between them, whatever you want.
Does the y have to be in front?
Nope, the y does not have to be in front. You could have had this as x, y6. It does not matter. These are both the same. Multiplication, it doesn't matter what order you do it. Now, if I have numbers, the same process goes. The 3 cubed, that's 3 times 3 times 3. This is 3 to the 4th. That's 3 times 3 times 3 times 3. This is 3 to the 7th. 5 to the 8th, 5 squared. That's 5 to the 10th. I can kind of write it out like that. But let's not worry so much about that. Instead, let's go to this one. Try to simplify that by combining all of your like terms. Do it on your piece of paper first before you do it on your notes. How many x's are being multiplied together? How many y's are being multiplied together? How many z's are being multiplied together? Yes. No, that's not right. That's a good question, though. But let's talk about that. What's x squared times, let's do that first problem, sorry. This is 1, 2, 3, 4 x's are being multiplied together. I'll multiply that by 1, 2, 3, 4, 5 y's that are being multiplied together. And I don't need the dot there. You can get rid of the dot. This is x to the 4th, y to the 5th, and then 1, 2, 3, 4, 5, 6, 7 z's are being multiplied together. Okay? Does not matter which order you put them in. You can put z's and y's and x's. You can put y's, z's, x's, whatever. Six options. Cool? What is x squared times x to the 5th? X to the 7th. What is x squared plus x to the 5th? Okay, this is important, and this is just an introduction, and we won't do addition until later in this chapter. But notice addition, the rules for adding things with exponents completely different from the rules of multiplying things with exponents. Okay, this is 2x's times 5x's. That's a total of 7x's being multiplied. If I have an x squared and I'm adding an x to the 5th, these are not like terms. I can't. You just leave it like that. When it's x squared plus x squared. What's 1x squared plus another x squared? 2x squared. Yeah, remember? Yes, you do. You've done this before. 1x squared plus 1x squared is 2x squared. That's like x plus x. X plus x is not 2x squared. X plus x is just 2x's. All right? So notice multiplication, addition, very, very different. Okay, let's go back. So the top was multiplying. Now we have powers to powers. Change this one from x squared to x squared cubed. On your blank sheet of paper, what is x squared cubed? X to the 6th is correct. Why? Because I can write this as x squared times x squared times x squared, and I can use that addition property and add 2 plus 2 plus 2 to get 6. On your blank piece of paper, try to do this one. Now, this dot is designed to confuse you. There are dots everywhere if you have things next to each other. That's 2 times x times y. If you ever see dots or if you ever see things next to each other, you're just multiplying those things. Write it on your piece of paper first. What is 2 times x times y squared? Not plus. No, this is y squared, not 2y. Y times y is y squared. Ready for the answer? 2xy times 2xy is 4x squared y squared. Let's do one more, and then we will figure out the rule of having a power to a power. If we have a bunch of stuff to a power, we'll be able to figure out the rule. We'll have another rule for this. So try to do this one. Try to figure out, and if you can do this without the rule, you're good for this chapter. We're just multiplying things together. Do not let this dot confuse you. There are dots everywhere. It's 4 times y squared times x cubed, all of this to the third power. Let's try to simplify that. Take your time. Try to get the answer yourself by writing it out. When in doubt, write it out. If you can get the answer by writing it out, we'll be able to understand where this rule will come from. Yes, that would be correct if you wrote it out. So the number is not correct. Neither is this nor that. Write it out. Everybody write it out. If you can write it out, you can understand the rule. What'd you get, Mr. Dollar? Nope. That's why you're doing it on your piece of paper first.
I got 64y, 66.
That's perfect. You're really close, Mr. Gunter. This is right. That's right. The y's are wrong.
Would you leave a number in front of the x?
Well, then you don't have 3 of these. You just have x times x times x times x times x times x. And this is just x to the 9th. Okay, you ready? Shh. Ready? This is how you would write this out. And this is how you do this without a rule. You'd say 4y squared x cubed, 4y squared x cubed, 4y squared x cubed. Does that make sense how I can write that out? It should, if you know what something to a third power is. Just multiplying this by itself 3 times. Mr. Suarez, question. Do you understand how I wrote this out? This is just 1, 2, 3 of those 4y squared x cubes. Yep. Okay. Well, guess what? 4 times 4 times 4 is 64. Guess what? Y squared times y squared times y squared is y to the 6th. Guess what? X cubed times x cubed times x cubed is x to the 9th. All right. Let's compare. X squared cubed, x to the 6th. X to the 8th times x to the 4th, x to the 12th. X squared cubed, x to the 6th. This 2xy became 4x squared y squared. This 4y squared x cubed quantity cubed became 64 y to the 6th x to the 9th. What's the rule? Mr. Conwell? Whatever exponents you have, you multiply these exponents. If you ever have a number, you would have to take that number to that power as well. This is actually 4 cubed, and then y squared cubed is y to the 6th. X cubed cubed is x to the 9th. A power to a power, distribute the power, multiply the exponents. That's the rule. You distribute the power to all the terms being multiplied. Now, this is going to really get confusing when we throw addition in here. But right now, we just have multiplication. If you just have multiplication, you distribute the power, and you multiply your exponents. This cube just goes to the squared. 2 times 3 is 6. This cube goes to the 4. 4 cubed is 64. Y squared cubed is y to the 6. X cubed cubed is x to the 9. Let's go up. Power to a power. Distribute the power on the outside, multiply exponents. Distribute the power to everything, multiply the exponents. This is the biggest difference here. Try to circle these two. If you can understand these two and the differences, you should be good with these two rules. X squared times x cubed is x to the 5th. X squared cubed is what? X to the 6th. Okay? These two differences are so important, and so many students forget these two differences. Okay, try this on your piece of paper. 3x cubed y squared. You now have the rule. You distribute the power to everything, and you multiply the exponents. Now, it's not like you multiply 3 times 2 times 2. It would just be 3 times 2. Nope.
Oh.
Who's very confident in this answer? Mr. Bladen, what'd you get? No. Mr. Ard? 9x to the 6th, y to the 4th is correct. Here is why. You are multiplying the exponents, right? You are not multiplying this exponent with this number. This is 3 squared. That's not 3 times 2. It's 3 times itself twice. It's x cubed times itself twice, x to the 6th. It's y squared times itself twice, y to the 4th. Okay, let's go back to that previous page. Skip this one. Let's do this one. Well, there's a property that we'll talk about that you'll get. Skip this one. Do 2x squared to the 4th times 5x to the 5th on your sheet of paper. When in doubt, write it out. Maybe try it using the rules that you think, and then maybe try it by writing everything out. Write it out if you haven't done it yet. If in doubt, write it out. If you're in doubt, write it out. Well, you don't have 5x 5 times. You just have 5 times 5x's. To the 13th, you mean? I believe that's right. Times. 16 times 5, not plus 5. 16 times 5. 16 times. This is all multiplication. Times. Okay. You ready for this? Now, over the course of this entire chapter, we will be practicing this often. Okay? Here we go. This is 2x squared 4 times. I'll show you how you can write it out. 2x squared, 2x squared, 2x squared, 2x squared. Now, what we have here is just 5 times x to the 5th. This is not anything else. You not have to write this out as anything different. Okay? That's how you would write it out. If you applied the rules, you would say, okay, 2 to the 4th, 2, 4, 8, 16. X squared to the 4th, x to the 8th, times 5x to the 5th. Now you can multiply 16 and 5, 80. You can multiply x to the 8th times x to the 5th, knowing that when you're just multiplying, you add the exponents. 80x to the 13th is correct. Ms. Clemens.
Why don't you add the big number?
Because this is all multiplication. It's 16 times x to the 8th times 5 times x to the 5th. There's no addition at all. It's all multiplication. Okay. Do this one, only change these negative exponents to positive exponents, okay? We'll talk about the negatives later. So it's 2a, here, let me just zoom in on this guy. Shh. 2a cubed all to the 4th times 3a to the 2nd power to the 3rd power. So positive. Now really quick, 3a squared, this is not 3 squared a squared. This is just 3aa. The only way you'll have 3 squared a squared is if you have 3a quantity squared. I don't have that. I just have 3a squared. So keep that in mind. Remember, we're just multiplying. We add exponents, but we multiply numbers. Is that 18 or 16 here? 18. Yep, I think that's right. If you need a calculator for these big number multiplication things, you can use one, okay? Ready? It's not 2 times 4. It's 2 to the 4th. 2, 4, 8, 16. This is a cubed times itself 4 times. That's a to the 12th. A cubed, a cubed, a cubed, a cubed, a to the 12th. It's not 3 times 3, it's 3 to the 3rd. That's 27. It's not a squared plus 3, it's a squared, a squared, a squared, that's a to the 6th. Multiply things together. Numbers multiply together. 16 times 27, 432. A's can be multiplied together. How many total A's are being multiplied together? 18.
Okay, so it's not by itself, but then exponents multiply it by.
Yep. You multiply numbers by itself that amount of times. With the exponents, it's the same thing, but the rule is you end up multiplying the exponents together. Next one, right here. No, that's a number. No, don't get rid of the negative. Keep that negative.
It should be first.
It's a horrible, horrible impersonation. Yeah, it was horrible. I mean, close.
I was a little close.
No.
Not at all. Come on, you gotta give me a little bit credit right there.
No. Use a calculator. You're not going to do 27 times 4. Figure it out. Do it on your piece of paper. You will then write it down.
It's a big one.
Yep.
Holy cow, that's huge.
All right, you may now compare your answers with the neighbor.
No negative.
Alright, what'd you get? What'd you get? I got 561. Yep, I got. Sorry, that's a good one. That's what I originally got. That's good. I went to the other room.
No, I don't know who that is.
Nope. Good observation.
We should get 6561 x to the 16th y to the 28th. Okay. Do the next one. There are going to be a lot of these that we're going to do. How is it y to the 28th? Because it's y cubed to the 4th, that's y to the 12th. It's y to the 4th to the 4th, that's y to the 16th. Everybody be quiet. No, just to that one. Good question. You can simplify that more.
I can simplify?
Of course.
Right.
Shush, shush, shush. Do it yourself. Everybody needs to do these. It's not going to help if you just wait till I put the answer up. We have to struggle through this. We just have one 6y to the 5th. I don't know why you wrote it down twice.
Where?
Right here. This is just 6y to the 5th. That's it. This is 2v squared. The last one is 2 of these 2w squareds being multiplied together. Ah, I see it. No, the 2 is just going with the last one. Shush, 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 shush. Really quickly. Be quiet. Be quiet. Shh. This 2 only goes with this last term. Does not go to everything. Keep that in mind and do this problem. Yes. What's up? That's right. Ask me a question. Ready? This is 6w to the 5th, 2v squared, 4w squared, which can be simplified. Sorry, that's 4w to the 4th. So, that's 24 times 2, that's 48. We only have 5 w's multiplied by 4 w's, that's w to the 9th, v squared. 2 times 6 times 4. Last one for this lesson, not today, but for multiplication. Two m squared, 4m to the 4th, 8n squared. No talking. Everybody does it individually. And wait till I put the answer up. Shush. Shush. You do it yourself, and let's see by a show of hands who got it right. That's confidence. I like it. Mr. Cross, is your hand still up? No. Okay. All right, who got this right?
Oh, I thought the 2 was inside the parentheses.
Nope. These are tricky. We will continue to practice these. Go back to the first page.
No.
Nope, the first page. We've done 3 rules. Well, 2 rules so far. We've done multiplying exponents. We've done power to powers. Okay, multiplying exponents, we figured out that we're going to add exponents, but we're still going to multiply numbers. So add exponents, even include here, multiply numbers. Then here, for the powers to powers, we distributed the power to everything. We multiply exponents. Make sure we take our number to the power as well. Okay? Last one, we're going to deal with these negative exponents. And these are completely new to you. So we're going to see if we can figure out the pattern for these negative exponents. So 3 cubed is what? 27. Okay, this is 27. 3 squared is 9. 3 to the first, 3. What is 3 to the 0?
1. I don't know why.
Type it into your calculator if you have it.
1, but I don't know. It is 1. I don't know why. Maybe it's 3 divided by 1, you idiot.
Kind of. Essentially, you can kind of see a pattern in why things to the 0 power is 1. What do you think 3 to the negative 1 is? What is 0.3 repeated? Make it a fraction, please. What is 3 to the negative first? 1 over 3. Shush. Everybody be quiet. Shush. Shush. This is 1/3. Just be 3. This is the rule of negative exponents. We're discovering it. Everybody be quiet. Everybody be quiet. Math, enter, enter. The second one, 3 to the negative second is 0.11111, which is 1/9. Math, enter, enter.
Wait, like without the calculator? Same with 1 over it. It's just a regular number with 1 over it.
Yes. 3 to the negative third is going to be what?
1 over 27.
Okay. The rule for 0 exponents, anything, shush, anything to the 0 power is 1. Look how it works out. It's like 3 to the first is like 3 times itself. 3 to the 0 is like 3 not being multiplied by itself, but it's almost like, where do you have to start? You got to start with 1, because if you multiply 1 by 3, then you get 3. So it's like 3 to the first is actually starting with a 1 times 3. 3 to the second is 1 times 3 times 3. 3 to the 0, no 3s, just the 1. So then we go to the negative first. 3 to the negative first, that's 1 divided by 3. 3 to the negative second would be 1 divided by 3 squared. That's the rule for negative exponents. Something to a negative power is just equal to 1 over anything to the positive power. This also could be applied, and of course I don't want to say anything. I could just say like a to the 0 is 1, or a to the negative p is equal to 1 over a to the p. This could also be applied if we have something in a denominator. If I have 1 over a to the negative p, what's that going to be?
1 over a to the negative.
1 over a to the positive p. What's 1 over 1 over?
1. 1 to the negative.
3 to the negative first is the same as 1 over 3 to the first. 3 to the negative second is 1 over 3 squared. 3 to the negative third is 1 over 3 cubed, right? Well, what if I gave you 1 over 3 to the negative second? What would that be equal to? Just 3 squared.
It's just the opposite. Wait, what? It's just the opposite.
The rule for negative exponents is you take the reciprocal, make the exponent positive. Write that down. Take the reciprocal, so you flip it. Make the exponent positive. Mr. Cross.
Can you have like a negative number and a negative exponent?
You could, but it's just the same rule. You flip it, you make the exponent positive.
Teachers, pardon the interruption. If you are a student that has baseball, third period, please go to Coach Mears' room again today, C207. Again, if you're a baseball student, third period,
Make the exponent
go
positive.
to Coach Mears' room, C207. Thanks.
Take the reciprocal, flip it, make the exponent positive. Let's go to the third page. Now, if I ask you to simplify something with negative exponents, you will get rid of all negative exponents by making the exponents positive. How do you get rid of all negative exponents? You flip the terms with negative exponents. You make the exponents positive.
Only the exponent?
Yes, only the exponents, not the numbers. One over x to the negative fourth. If I ask you to simplify it, pay attention. 1 over x to the negative fourth. What can that be simplified to be? This is x to the fourth. Don't pack up, Mr. Suarez. Yeah, wait till you're on your way out the door. Flip the terms with negative exponents, make the exponents positive. Skip this one. I just told you why. Now, here's very important steps here. This is a 7 times x to the negative third. The x to the negative third and the 7 are not tied together. Even though they're next to each other, this negative 3 is not with the 7. It's by itself. This y to the negative 5 is not with anything else. It's by itself. If I ask you to simplify this term, what would happen is that the x to the negative 3 would come down and the exponent would become positive. The y to the negative 5 would move up and that exponent would become positive.
49 divided by 7.
And then it would be 7 divided by 49 because a to the 0 is 1. This is starting to get crowded. Let me just show you this. We'd have 7, the y to the 5th becomes up. We'd have 49. A to the 0 is 1. Stop packing up, Mr. Sharma, especially if you're going to complain after we do every single problem. X to the positive, you be quiet too, Mr. Dollar. Now, the last step is to simplify things we can simplify. 7 divided by 49 is 1/7. This would be the simplified answer for this guy. Negative exponents, you move them and you make the exponent positive. That should be the simplest rule, but it's definitely the newest rule that is the toughest to explain. We will continue with this packet of notes. Do not lose this. You will see your homework online. We will have a quiz next class. Everyone. This is algebra.